Hello everybody. How you guys doing? Pretty good. Good. I have research paper information for you, although I've not yet put together a portal for you to select which component you want. I'm going to do that. I'll have that available for you Wednesday so that you can kind of select, you can kind of slot yourself in, hey, I want this this particular topic, this subtopic kind of thing, so that we can organize something that is meaningful in terms of being able to, not have everybody do the same exact topic. So that's my plan. I wanted to talk a little bit about it today before we get into kind of an overview of key contaminants that we'll be thinking about for developing context. So let me see if I can just do this. Here we go. All right, so as you saw when we talked about the syllabus, we have kind of our individual term research papers. So I'm laying out here kind of the expectations, what that is, what that looks like, and we have the deadline here. So we've got a deadline to select your topic by a week from today. So not too difficult there. And then by the 23rd of February, I want each of you to have essentially formalized your thesis statement for the paper. That's probably going to revise as you go forward, especially as you start digging into the literature. But I want you to start with something that you can make a statement that you're going to construct your arguments around, right? And I want to be able to give you feedback on that and give you all a chance to give each other feedback on that. So this will be something that you present in class. It'll just be, a 1 to 2 sentence statement. It's like, hi everybody, my name's Sam, here's my statement, blah, 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 blah. So we're going to start practicing presentation skills, communication skills in articulating your statement and in standing up in front of the class and expressing it. You don't have to be all the way up here, we're not going to do PowerPoint or anything, but it'll give you a chance to say, stand up and say hello, all that. Okay, so that's kind of what I'm thinking for the thesis statement. I'm also going to have you submit to me that statement within the context of an introduction paragraph. So the assignment essentially is by the 23rd, you'll have, by next week you'll have a topic selected. By the 23rd you'll have thought about it enough to write an introduction paragraph with a statement there, the thesis statement. So you might have to think back to maybe high school or something about argumentative essays. This is essentially what I'm asking you to do, is formulate the argument that you're going to make, right? Again, you can adapt it, you can revise it. I expect you to adapt and revise it based on feedback, but that'll be the statement that I'm asking for. I'll have the paper copy, so you'll submit that through Moodle to me, then I can give you feedback specifically about your statement in the context of that intro paragraph. Okay, so I hope that'll orient your paper writing. Then you'll have a draft of it due on April 4th. So a little over a month later, you'll have to give me a draft. I don't have a huge requirement there. I think I said 2 pages in here. Essentially, I want to be able to give you feedback on your writing. So if you're making a repeated mistake, I want you to know that before the final grade comes due and I'm like, hey, you made this mistake 100 times in your paper. That constitutes lots of grammatical errors. I'm going to go through the rubric for this assignment in a minute. So I don't want that to happen. I want you to have a chance to course correct for that kind of stuff, course correct for any, maybe you're lacking depth in content, or maybe you're not citing your references properly, something like that. I want to be able to give you that feedback there. So I need you to write enough for me to do that, which is probably about 2 pages of the assignment. I'm asking you to keep to use 1.5 line spaces, and then ultimately expect for undergraduates somewhere in the ballpark of 4 to 6 pages. You can do more than that if you like. That's kind of a ballpark expectation, and then with that, grad students would be 6 to 8 pages. 1.5 space, so I have a little bit of room in the margins to write back to you. So then another expectation I have is for you to use a software platform of some sort. I use Endnote, and I'm going to show you that in class. but it's a software platform that can integrate your references into your writing. So I'm asking you to do that for your own sake. It'll take a little bit of learning if you've never used one, but kind of your reference management, bibliography stuff becomes a lot easier when you use a formal citation manager. That'll help you in any writing task you have where you're making some sort of references. Okay, and that, by the way, is free. LSU's software system. You can get it for free, which is another reason why I'm requiring you to use that or something similar, so that you you become aware of the utility there. Okay, so I'll show you that. I'll spend a couple minutes on it today, and maybe a more in-depth workshop later as well. All right, what else? So I'm asking you to kind of using that platform to arrange your citation references according to typical journal formats that we might have in environmental science and technology, for example, is one of the journals. Something related to our field, pretty much standard scientific referencing kind of a system. You could potentially use like APA. That's not what I'm asking for. I'd kind of rather you learn how to do it for this particular journal in case you ever on a journal article, or when you're looking through them, you'll kind of recognize, oh yeah, this is typical. They put a little numeral at the top, at the end, or something like that. Okay, I kind of went over this as I talked about the deadlines, but for the submission requirements, we'll have a thesis statement, a draft, and a final submission. One thing I want you to do is keep all of the feedback I give you. So when I return some sort of feedback to you, whether it's electronic or physical, I want you to collect that and turn it all in, or a copy of it all, you can save a copy for yourself, into me at the end of the semester so that I can see where you've improved, okay? So when you have a document returned to you, save it, save an extra copy somewhere, so that at the end of the semester I can grade you based on improvement rather than your final product. Because if your final product kind of sucks but it's a lot better than where you started, if you can show me where you started and you keep all that record, I can be a lot more lenient and forgiving or positive about your grade because I see your progress and your learning. If I have to grade just on the final product and you're making the same grammatical mistake every time, that's kind of what I'm grading on. So it's to your best interest to do that, and that's kind of the spirit of the communications intensive class here, is to have that critical feedback and improvement process. Okay, I'll come back to the topics in a moment, and there's maybe a little bit of wiggle room. If I miss something you're really excited about, we can talk and perhaps add one more or adjust a little bit. For the rubric, it's a whole bunch of text here. I'm going to post this on Moodle today, so you'll feel free to read this to your heart's content. Essentially, what it is doing is it's categorizing several topics or several aspects of your writing, right? The integration of knowledge from the course and from your references into the paper, that's number one. And we have definitions of what constitutes excellent versus medium, good, unacceptable quality, right? And I'll give you a couple examples in a moment. Then we've got topic focus and cohesion. How much do you stay on track? How much do you kind of relate ideas across different papers into your topic? Maybe addressing other topics that are tangential, introducing them as appropriate, not going off on wild goose chases to talk about this topic when really your paper's about this other one. The depth of discussions, spelling and grammar, and then sources. Essentially the sources that you've chosen and the way you're citing them. Is it appropriate? Is it professional? All that. Okay. And just to kind of show you what that's going to look like grade-wise, is I'm going to distribute those into, you'll have a grade for that intro paragraph. I'm going to take essentially this rubric, apply it to your intro paragraph. You're not going to have written much, so it's going to be relatively simple. It's a way for me to give you some feedback. Like, maybe not all of these are going to be appropriate, right? You might not have any citations, in a few weeks when you submit that intro paragraph. You probably should have some by the time you submit your final draft, but I'm not going to be so critical on that. So I'll give you some sort of a grade here, but it'll be that improvement across here that I'm looking for, right? So that final grade is really going to be the majority of your grade, and this is kind of just how I'm going to track it. Question?
Yeah, so when you're saying intro paragraph, but I thought you just wanted like 2 sentences for a thesis. Do you want us to write a whole introduction paragraph?
So it's a good question. Let me clarify. The thesis statement that you will present in class is just 1 to 2 sentences. Mm-hmm. That's your statement. This is a problem, and here are the related issues, and I think this, understanding this aspect is critical to solve this nation's problem. That might be your thesis statement, but that would be in the context of a bigger paragraph, right? That's going to be in the context of your introduction paragraph, most likely. So what I expect is for you to write an intro paragraph,
and only
highlight that thesis statement and present that thesis statement, but turn both of them into meat.
Okay.
And I'll talk about it again when that comes due. Okay, so for this intro, that'll be a paragraph that includes your thesis statement. So for each of these categories, I might rank something like, okay, this is a 4, this is a 3, a 2, and a 1 in terms of points you get for that particular category. If I determined you had good quality of integration of knowledge, which this says the paper demonstrates that the author, for the most part, understands and has applied concepts learned in the course. Some of the conclusions, however, are not supported by the body of the paper. Okay, so for example, you can take a look through there and see how I would be relating your work to this rubric and therefore assigning grades. Okay, so my idea here is I'm going to aim to be very critical, especially on the intro and draft, so that you can improve the most, right? And then, I'm not going to be intentionally overly critical for the final, but it is I am expecting improvement above and beyond when I gave you that harsh criticism, right? So that is putting some high expectations on you, but not in a way that's going to be unmanageable is the hope. Okay, so this will be posted. You can take a look. I'll go ahead and show you Endnote before I get to discussing the topics real quick. So I'm going to just take a new Word document here in my Endnote program. Okay, so this is Endnote. This is a slightly older version, but it looks very, very similar, the current version, so I just need to upgrade it. I have an Endnote library here. I'm going to go ahead and make a new one just so I can run you through the scheme of it. So I can make a new library, maybe it's a new paper, maybe it's a new topic that I want to talk about, and I need references in here. There's some sort of a search feature where you can search the internet through this platform. I don't really like doing that. I'd rather personally go through just a website and export that file, which Endnote will take directly. So let me set this up. Okay. So there's a couple ways I typically will do it. Maybe I'm just doing a Google search and I come across some journal that has papers that I'm interested in, or I find a paper title that looks interesting. I read the abstract and say, hey, I want to read this. So then I go through LSU libraries. Maybe I'm just going to go ahead and start signing in here. Okay, so here's a journal site. I mentioned ES&T, Environmental Science and Technology, earlier. If if I take a look at some recent articles, see what the special issue's about. Let's say this particular critical review is very interesting to what I want to do. So I find that specific article on that specific website. Anytime you find this, no matter the journal, there will be some way to export that reference. Okay? So if you're just browsing based on who knows what journal, but you find it, there's going to be some export function, and right here, you can see it right here, the export, RIS, that's a reference indexing service, I think is what that stands for. I usually send the abstract and citation, and I'm going to go ahead and open it with what's kind of the default that'll give it to Endnote. So when I do that, you'll see now I have that specific article in my Endnote library. Okay, so that's one way to do it. I could also go to Web of Science through the LSU libraries. Highly recommend this as a search tool for your research content. Obviously Google can work, but here you can search specifically for, let's say, Haiti, and I'm going to put a star there, so it can be Haitian, it can be Haiti, it can be whatever, and cholera. And so this is giving me 549 results. I can filter them in different ways based on maybe the impact or how many times they've been cited, how many references they cite, and then I can sort through those as well. So maybe this is the one I'm really interested in, or maybe I'm fairly interested in that, and I can export that to my EndNote. I can send it like that. But I'm also interested in who cited this paper, so I can search those as well just by clicking there. So this is a very helpful tool for looking through papers. If you're not familiar, you definitely should get familiar. So now I have that new reference as well, so I have a total of 2 references. All that information collected there, all their bibliographic information. So now, when I'm writing my paper, let's show you this in, let's say I'm talking about cholera in Haiti, then I need a citation for that one, so I'm going to take my, not my inorganic nanoparticle stuff, I'm going to take this probability of cholera extinction in Haiti, and I'm going to click a button, and then it inserted it for me. And not only did it insert it for me, it inserted the reference. So all that work done right there, okay? So if you're in senior design and you're making a report, highly recommend checking this out. The other thing it'll do is it'll number them. So in another topic, I'm talking about this other technology or whatever. And I hit that insert button. I highlight it, insert it, there's number 2. And then if I go back to cholera, and I need that citation again, and I insert it, well now I've got it listed, that first citation 1, numbered this 2, and then it knows that's number 1 again. So it's tracking all that reference management. I can delete number 2 here, and it'll just eliminate it. It just does it all for me, right? So it integrates into Microsoft Word. There are other programs that'll do this. EndNote can be a little bit annoying in some ways, but by default, it's quite impressive what it can do if you've never used something like that. Okay, I can do better explanations, more of a workshop on that to help you get started with that later. I wanted to show you what that is and kind of why I care about you using it, right? Has anybody really just wowed by that or completely had not seen anything like that before? Okay. Well, good. Because I know some people, maybe you've already seen it, maybe you've had it or used it before. So I'm never quite sure. Okay, so anyway. that's the reference management software. I'm expecting you to do something like that so that you save your own time. As you saw, it gave very nice reference information, and if you don't give me that, I'm going to be doubting whether or not you use something like that. So either you have to spend a lot of time being very meticulous with the reference, or you should spend a bit of time learning a reference management software system and save yourself some time forevermore. Okay, so topics that I identified I thought would be good, in part based on your feedback. First of all, there's subtopics, but the bigger topics here, I'm going to go ahead and put the Haitian Disaster. This is really starting in around 2010, or maybe it was 2008, earthquakes, followed up with some pretty big issues. Actually, the UN aid workers came in, I think from Nepal or somewhere, brought cholera, and introduced cholera to the community that was hurting by accident, of course. And then that's been an epidemic that's been rampant ever since, essentially. So that's a major issue, a lot of kind of ethical and other concerns. We're aiming to help, and they really hurt in some ways. So there's that. Given that a lot of us are hoping to go to Nicaragua, I'm putting Nicaraguan poverty in general, or just their the general state of the country and development needs there. Indoor air pollution in developing contexts. So I know most of our class here is devoted to water quality, water treatment. I'm adding this as a separate one. If you happen to be somebody really specifically interested in air quality, you're welcome to do that for the writing. Obviously, not all of our course knowledge is going to integrate to that, but there obviously is some. Okay, soil transmitted helminth infections. These are essentially parasites. Guinea worm, for example, would be one of them. Arsenic in groundwater supplies. I specified Southeast Asia. There's a lot of this in India, Bangladesh. So I specified that. Of course, if you really wanted to, you could identify another location. Okay, contamination in private wells in rural U.S. Talked a bit about that. I think that's certainly worthwhile as a topic. Illicit gold mining operations. There's really a lot of economic considerations here, given how lucrative these operations can be to locals, and what are the implications there in terms of, like, you know, how are you going to show up on their door and say you should stop this when they're finally able to feed their family or whatever, you know, and maybe save for their kids to go to school or something, you know. That there's a lot of you know, obviously it's not a good thing when, in most situations, when people are exposed to toxic heavy metals and are kind of destroying their environments. But on the flip side, there's issues, right? There are important considerations there. So I think that would be a good one, and that's a little bit separate from kind of impacts from unregulated or poorly regulated industries. I mean, that's obviously the same general topic as illicit gold mining. I think it's a little bit of I think the gold mining situation is a little bit unique enough to warrant kind of a special attention there. So this one, I'm asking, if you choose this, then as a group you would specify 1 to 2 industries in particular to focus on. Maybe that's textile dyeing processes, maybe that's e-waste recycling, something like that. And then last, so the strain of climate variability, and I'm asking you to specify a country or region and focus on aspects relating to environmental quality and infrastructure. Okay. What do you guys think about that? Good topics? Missing something you really wanted to not see? Okay. So, unless I hear from you, earnest email like, hey, I want to talk about this, I want to write about this and learn about this. Unless I get some emails like that, this will be the topic list for our class. And then what I'd like for each of you to do is to essentially, so once we sort into the big topics, then we're going to select subtopics that you may be specifically interested in, to take that slant for your paper and for your part of the group presentation. Okay, so this will sort you into groups. I've got, I think, 8 topics here, so that gives us, I think, 3 to 5 students per topic is reasonable. I guess maybe sometimes we could do 6 if we've got, I think we've got 6 subtopics here from counting, maybe 7. So at the very most, it would be 7 students in a topic. Probably aim to 3 to 5. That'll be easier to present, easier to work together for that. And we have enough topics so that, 37 of you divided by 8 is less than 5, right? So I think that should work. So then in your paper, I would like for you to be cognizant of all these subtopics, focusing on 1 or 2 of them. So for your paper itself, be focused, but integrate the importance of the other pieces. Maybe you just take a very economical approach. Why does the economics of this water treatment system, why is it so important to make the toilets economical and something that the locals are going to adopt and pay for willingly? Well, there's maybe some cultural aspects that are involved and stuff, but most of your work was an economic analysis, right? On the flip side, somebody might be digging into the culture, why this is taboo, what's the history in that region, why don't people use any sort of protected toilet environments, right? Something like that. So does that make sense how you can kind of focus and then integrate for your presentation? Okay, great. So I'm going to essentially I'll probably make a Google Doc and let you guys fill in your topic and a subcategory. You just put your name in there, lock that in place, and I'll have that ready for you on Wednesday so that we can sort that way. So I'll give it to you Wednesday. It's due by Monday next week. Okay, the selection. All right. Any other questions, concerns about the research paper? Okay, so I just have a bit about kind of key contaminants that we're going to be looking for. Essentially what I want to do today is kind of take a brief look at something you've seen before, at least in 3110. What are our typical approaches to water and wastewater treatment when we have the infrastructure in place, and then start thinking about, okay, well, what would it look like with no infrastructure? How do we make decisions? What should we prioritize? So that's kind of the approach today. We'll get into more details next time with kind of a technological approach. Actually, what I ought to do is kind of just take a glance with you through the syllabus to see kind of where we are. I did post the recorded lectures from last week this morning. I meant to do that last week, but those are up now on the YouTube links. I'll post those to Moodle, but they're on YouTube now. Okay, so just real quick, kind of this is today. We'll get into a little bit of this, and I think maybe that'll be a little bit redundant, so we might just kind of speed up that and get into the point of use technologies next time. Okay. All right, so with that, so if you've taken almost any class with me before, you've probably seen me draw my silly fecal-oral route of transmission toilet drawing. So essentially, the primary thing we really care about with water treatment, whether that's wastewater or drinking water, is we're trying to avoid the fecal to oral route of transmission. So if we have some river here and it's flowing along, essentially what we want is some water supply. So we want to be able to take water into our cup and drink it, right? And we want that to be safe and not contain any stuff that's coming from some sort of fecal matter, right? So What really we are interested in is protection against the fact that upstream there may be some toilets. Right? So if these are discharging into the water, then it's flowing along, and then you withdraw that water to drink it, that's a problem. It's also a problem if you have some sort of a stick figure animal. Give it a couple of years. Well, maybe not quite. Mostly stick figure, right? I don't even know what kind it is. Maybe it's a sheep. If that's adding stuff to our water, that's a problem as well. This is not even to mention the role of mosquitoes and things like that. It's not quite the same as for fecal oral, but disease generally. So anyway, what we want is a barrier to the waste. So this would be our sanitation wastewater side of things. We want a barrier there. So that would be our wastewater treatment. And we want a barrier here for our drinking water treatment. It's ideal to have both because unfortunately, you still have animals around, you still have contaminants in the water, typically, especially for surface water, even if you have perfect wastewater treatment, right? So if you're going to take from the surface water, you're really going to need the drinking water control. Now, if you're taking from really fancy, pristine glacier water melt, maybe you don't even need anything, right? So long as you're protecting that glacier. That's not very common, so we're not really going to assume that that's the case in almost any time. But essentially, you have to be concerned about that fecal oral route of transmission almost anywhere you are. You want to mitigate any human waste entering because that is a very high risk, and you still want to treat it just in case because animals and natural bacteria are going to play a risk. Okay, so the water supply itself is a big driver for what do we treat, how much do we treat it. Are we taking, again, that glacier melt, or are we taking from some pond or reservoir? Maybe a stream flowing down a mountain is pretty safe. Not so much the bayou down kind of the bottom of the Mississippi River Valley, right? That's probably a lot more contaminated than some snow melt from the mountain. Groundwater can be pretty good, but it kind of depends on the quality of the aquifer. We have other contaminants to be concerned about, and it's going to depend on how deep you go. If you're just digging a well as deep as it takes to find water, and you're a rural community and you don't really know what you're doing, but you found water, great, but how contaminated is that kind of surface level of surface aquifer there? The water table is probably contaminated with any pit latrines or whatever else is nearby, so that's not necessarily safe, even if it's a little better and less muddy maybe, if you've got a decent control of the well construction itself. Maybe you've got a little bit of filtration so you don't have as much turbidity, but you still have potential problems there. In kind of a developed or infrastructure heavy context, we might think about, okay, we'll design our water treatment system based on where we're getting that water. And then of course we'll use that water and then send it to a wastewater treatment plant. So the question kind of for us is, what do we do if we don't have that centralized system and we need really a point of use, POU, or a localized, maybe a community scale system? We really have to think about, okay, well, what specific water do we have to work with, and how are we going to treat that? And how are we going to avoid contaminating that with our waste? So just a little bit more here on the fecal oral route of transmission. We know that it's really important. Typhoid fever, for example, is really, is a big one that once we started chlorinating and really got control in the U.S. of our water supplies, by 1950s it was pretty much gone, right? And we saw it when we started chlorinating, and the more sanitation infrastructure we had, it was dropping rapidly, right? So this is both, I would presume, proper wastewater treatment and better drinking water treatment. Chlorination providing a big impact there. And there are places that still have typhoid. So this typhoid is a pretty bad disease, can be deadly, and it's preventable. It's the fecal oral route of transmission. So that's a big part of what we care about here is preventable burden of disease. So diarrheal diseases are almost always this, the fecal oral route. That's preventable. We know how to prevent it. Disinfect, treat our wastewater, we separate those two as far as we can, and we can prevent it. So that's really a large component of what we care about, is mitigating that burden of disease that we have that control over. Coming back to kind of our standards in the US, which, by the way, a lot of countries will adopt either the US EPA standards or something like it, maybe change things a little bit so that to suit their own needs. The UN has some recommendations. I think Nicaragua tends to follow the EPA as best they can, at least in terms of their written regulations. So in the US, we have national standards for toxins and pathogens. We split that up into essentially primary and secondary standards. Secondary being really aesthetic. Maybe the color has no impact on the safety directly. You can have tea, for example, is very colored, but not any harm. These are not enforceable, would include the temperature, the hardness, the odor, whereas we have primary standards which are enforceable and really relate to health impacts. And we can classify these into chemical, microbial, and radionuclides. Okay, so that's kind of our classification. We have standards for all that. Recommendations for the secondary. Hardness, for example, changes throughout different parts of the country. This would be true of different parts of the world, obviously. And so, again, that we can use this just as an example to say, well, certain areas that have hard water are often also at risk for arsenic. If they have heavy mineral content, Michigan, for example, has a lot of iron and arsenic pollution, especially in that region that's highlighted in red there. So it's not always going to correlate in that manner, but sometimes it'll correlate. And it's just good to think geographically what's causing potential contamination and when is it potentially not going to be a problem at all. In a standard surface water treatment plant, large municipal facility we have in the States, for example, this is what it would look like. We've covered this in 3110, maybe other classes as well. Essentially, you're going to treat some surface water, so you screen it, then you do some primary sedimentation. Usually then you'll add coagulation, give that time to flocculate, do sedimentation again, and or some sort of filtration. Then you're going to disinfect and send it along its way. So, big question is, how do we condense all of that stuff, or the important parts of that stuff, into something that can happen in one point-of-use device or process? Because if you can take a water bottle, add something to it, shake it about, and let it sit there for an hour, and that fixes the water, maybe you can capture several components. In fact, there are some things we'll talk about that can kind of do some of that. It's going to depend again on what your quality is, but there's a lot to think about in terms of, okay, how, which problems are we really trying to address, and what's the priority to address in terms of pollutants. Okay, so we'll go ahead and get aesthetics out of the way first, because it is kind of important. Obviously, if it's an aesthetic concern, it's safe, but it's just not pleasant, right? So the important aspect of aesthetics that we ought to be considering is whether or not the user is going to actually drink it. Are they going to drink from the river instead of this chemically tasting chlorine stuff that, you don't trust the people bringing it? Maybe they're trying to poison me. This tastes bad, tastes like it's going to kill me. Maybe I should just drink my river water, right? That's a legitimate concern, and that's something that does actually happen. So in terms of chlorination in particular, we ought to be considering what's going to be acceptable aesthetically by a given community. So maybe the answer there is education, which is probably a topic I should have included as a subtopic, honestly, education generally. So education may be the right solution here so that people understand that it's okay to drink this and here's why. But perhaps we can avoid that altogether and not have a situation where we feel like, oh, you poor ignorant person, let me educate you here, because that seems like a bad take, right? Not saying that education is not important. We should, but if we can avoid that type of approach where it's like, oh, hey, you're ignorant, so let me help you accept my help, right? That seems like a bit the wrong direction. Okay, otherwise health impacts, and really what we're coming from is burden of disease, like I mentioned. So that's our quantification tool. I might come back to that next time, but what kind of burden of disease can we avoid? There's several metrics of burden of disease from the kind of the public health standpoint. How young is a person that's getting sick? Is it impairing their growth, their development? If diarrheal disease is so common that a child grows up malnourished and sick, even though they grow to a healthy adult, there's unfortunately very likely that malnourishment held back their mental development and perhaps development otherwise. So there's really a lot to what might sound silly is, oh, you have diarrhea, poor you, right? So a lot of us in kind of the developing context will get sick every now and then, and maybe it sucks for a few days, but it's not anything that we think twice about aside from just gross, I was sick, right? So it sounds maybe trivial for us, but this is at such a large burden of disease and the cause of death that it is quite important. Okay, so diarrheal disease in general, typhoid, parasites as well. There's so guinea worm. I think there's another one, schistosomiasis. I think that's the elephant's foot disease, if I'm recalling correct, and river blindness. All parasite type pathogens that are essentially from parasites in the water. Actually, I was reading about river blindness. That might be a mosquito-borne. But anyway, we have a lot of parasite things that if you're exposed to water where these parasite eggs are in, which again, fecal to skin exposure in that sense. So that's essentially going to be a wastewater thing typically. Some of them are drinking fecal oral, so that you ingest the eggs and then they become a parasite. Wastewater is often the treatment there, not every case. So wastewater treatment is what I mean. Okay, maybe your region in particular has specific issues. So again, if we had to design a treatment, it's really important to get as much information about the water that they're using before we suggest a solution. So it might be nice to provide a one-size-fits-all solution, and maybe we can do that to an extent, at least for the disinfection aspect. We know that if you use this chlorine or if we use this UV device, then we know you'll have a certain amount of disinfection because we tested it in the lab and we know that, right? That helps, that's good. But if there's also a lot of arsenic in that water, maybe we're not really treating the biggest problem. So knowing that would be really critical. Nitrate is that's NO3. That's not particularly toxic itself, but if you have a lot of it, it can cause problems, health problems, especially with babies. You'll have some blue baby syndrome. Essentially, nitrate in infants can end up competing with our oxygen receptors, and so you'll have essentially lack of oxygen because of the nitrate in the system. If we drink water that has a fair bit of nitrate in it, we'll probably be unaffected. But yeah, it can be a problem, and I think it may be chronic problems as well. Fluoride is an interesting one because we like a little bit of it because that really helps with dental health. It's a phenomenal help. We also sometimes use it as a tracer test to see what's happening inside a water treatment plant. Kind of serves both of those purposes. But if you have too much of it, and I mean a lot more than we add to our water, is sometimes found in natural groundwater, it can be pretty bad health effects. So I think there was a place in, I think I met somebody that was from Kenya or one of the neighboring countries that were very concerned about it because they have really high amounts of fluoride. So that can be a potential issue, the F minus, right? And of course, if there's some sort of industrial waste nearby or maybe overuse of agricultural pesticides getting into the groundwater or the surface water, that would also be a big issue. So the WHO has a few guidelines here. This is from our book. For common contaminants, for example, arsenic 0.01 milligrams per liter, fluoride 1.5 milligrams per liter, nitrate is 50 milligrams per liter, so that's quite high actually. If I were to test my aquarium today, it would probably be somewhere like 5 to 10 milligrams per liter, if that. I haven't been feeding my fish a whole lot lately, and there's enough algae and stuff that I'm probably consuming some of it. E. coli, they're recommending essentially 0 per 100 milliliters. As a reference, if you're not familiar with metric systems, 270 milliliters is 1 cup. So if you're thinking about that. So in about a third of a cup, what you want is to not be able to find any E. coli or this thermotolerant coliforms. That's a general test for different bacteria that can grow in a warm environment, like a gut. So it's an indicator, right? We're using this as an indicator of fecal pathogens. So if we can grow something that's like the conditions in our gut, then maybe we have some issue there. So that's a general test, and what they say is you should not be able to detect anything in that third of a cup, essentially. So you filter a third of a cup, and then you test that to see if anything grows. Now, maybe you have a count or two when you get up to a full liter or so, and that shouldn't be too much of a problem. Now, if you were to take a sample from the LSU lakes, I'm pretty confident your result here will be, if you tested 100 milliliters, you'll have too many colonies on that little plate that you tried to put them on to count individual colonies. So you'd have way more than, let's say, 200 in 100 milliliters. So that's just as an example. These are out in the environment. Even if we have, control over our wastewater in LSU lakes, shouldn't be much going in there. But just natural environment, natural, wildlife and stuff, there are some of those in there. So this would actually be reasonably clean, is essentially what they're saying from a biological standpoint. Okay, then we have turbidity, and this is 0.1 NTUs. That's a turbidity metric. Talk about that. I think I didn't quite get to putting that slide in, so we'll talk about that next time probably. Arsenic, 10 micrograms per liter, and fluoride is on here twice, 1.5 milligrams per liter. Okay, so that's kind of just a few examples, and again, the heavy hitters in terms of what we know we might be concerned about, or we generally would always want to check for. Okay, so then one thing to consider as we think about how to approach removal of these contaminants, the first idea might be, well, let's filter it, right? Let's send it through some sort of a filter, and we'll remove everything larger than some certain size, and problem solved, right? That's kind of our maybe one first thought, because it's a physical thing, right? That or sedimentation, and then we can think about how big of a particle can we settle. We add some sort of flocculation agent, so a coagulant, flocculate the stuff. How quickly can we settle that? Right? We've talked about these technologies in our 3110 class, so that these are going to be kind of the first things to think about in terms of what can we do with a filter or with a sedimentation process. So if we think about, okay, well, what does a bacteria take? That's going to take some sort of microfiltration. So most bacteria are about 1 micron, so micrometer, or bigger. Some maybe a tiny bit smaller. There's a very common, if you work in a lab, you'll find a couple different size microfiltration filters. Typically, their syringe filters are going to be 0.45 micrometers or maybe 0.22 micrometers. So very standard microfiltration, and maybe getting towards the ultrafiltration side of things. It's kind of right on that category mark, right in that area. Those are very common, and so we also have very common membranes of that, larger scale membranes, something you could apply to maybe a community scale system. We'll talk more about that, I think, next time. Essentially, that could get rid of pretty much all of your bacteria, right? So that would do a pretty good job with the bacteria. Maybe occasionally these will eventually get damaged and some bacteria get through, but hopefully it would still be doing eliminating most, if not all, the bacteria. You'd also get rid of the algae, cysts from parasites or protozoa. So something like Giardia or Cryptosporidium would be eliminated by that. Whereas if you were thinking about just a conventional sand filter, you pour it through the sand, you're kind of doing essentially doing what happens in groundwater, is taking a sand filter. You're not necessarily going to get all of them, at least size-wise. Maybe if you add some coagulant, you'll get them to stick to the sand and all that. You might be able to remove some cysts. So some of the helminth eggs, for example, are probably up in this range, if not larger. So you can actually get rid of some parasites even by using cloth filters. So that's one solution to guinea worm, is if you take your water, first of all, avoid exposure to contaminated water, but also then take your water, just filter it through a couple layers of terry cloth, then you do a pretty good job eliminating that risk in terms of ingestion. So even the most basic filter that, as engineers we might think to ourselves, well, there's really nothing stopping bacteria from passing through that, right? That's not a solution. May actually be helpful for that particular case. Okay, of course, cost for if you're doing a membrane, or maybe the amount of gravity required to pass water through a sand filter. These are important. We have this table captures that flux versus operating pressure. You can take a look at all of that. If you really want to get down to eliminating viruses, you have to get down to pretty far into ultrafiltration, and that's getting up the price. The membranes themselves are going to be a little costlier. It's going to be costly to operate them. You're going to have some kind of technological way to pressurize them above and beyond just a gravity feed system. So that's getting pretty cost prohibitive in most cases, and getting to the point where we're not really practical for the most rugged situations. If you want to get down to removing arsenic, you really have to get quite far down there. It's not really going to be a practical consideration for kind of developing context. So that kind of gives us a few ideas of what might we be able to do with kind of the conventional systems there. Now, talking about arsenic, there are sort of cheaper ways to deal with it. If we do an oxidation process, sometimes just bubbling air through it can help, and then you can cause it to precipitate, change its oxidation form, create a precipitate, and capture that with sedimentation. So there are options there that we can get into. Okay, so I spent most of my lecture prep time preparing the research paper stuff, so I'm a little short on the slides today, but we'll pick up here next time and start talking about some of the point of view stuff. We've got a little bit of time. Is there anything you guys wanted to ask, talk about for now? Do you want a soapbox or just get on with your day? Okay, so we'll talk next time. See you on Wednesday.